Well, good morning, everybody. Today we are continuing 10-2 comparing data sets. In this lesson, we'll be looking at more than one of the dot plot, box plot, or histogram in one problem. And before that, let's review on how to find the center and the spreads of a set of numbers. So here we have a set of numbers. They are listed from least to greatest: 2, 3, 4, 4, 6, 7, 8, 12. In the past, you probably have learned how to find the mean, median, and mode. Those are the three types of centers in a data set. Well, let's talk about how do you find a mean. So in the past, to find a mean, we are going to add all the numbers together and then divide it by the number there is. So there are 8 numbers total. So what we're going to do as part of the work is to add up all those numbers. So you're going to write 2 plus 3 plus 4 plus 4 plus 6 plus 7 plus 8 plus 12, and then all of them divided by 8. So you're going to draw a long fraction bar, and then you divide it by 8. Now, this might be a whole number, this might be a decimal, we don't know. So let's add them together. 6, 7, 8, 12 divided by 8. And it turns out to be 5.75. So that means the average, the mean of these 8 numbers is 5.75. Well, to find a median, you sort them out from the least to greatest, and then you find the middle number. So let's actually count. I see there's a 2, there's a 12, so you took one pair of them out. And there's a 3 and X, you took one pair of them out. You took out a 4 and 7, you took one, you took a pair of them out. And then you left with 2 numbers in the middle, 4 and 6. Now, in the middle, if there's only one number left, that's your median. But if there's 2 numbers in the middle, right, then you're going to find the average, find the number right in between them. So to find the middle number, you just add them, and then you divide it by 2. So 4 plus 6 divided by 2 is 5. Or you could argue that 5 is right in between 4 and 6, so therefore the median is 5, okay? Now, mode is the number that appears the most frequently in the data set. So which number seems to be appear more than once or appear the most? It is the number 4. So the mode in this case would be 4. Now, sometimes a data sets have no mode if all of the numbers appear only once, or sometimes there'll be more than one mode if there is a number or more than one number appears the same amount of same number of frequency. Let's say if there's 2 7s and 2 4s, then your mode is going to be 4 and 7. There might be 2 answers, 1 answer, or no answer for the mode. But in this case, there is 1 answer, which is 4. Well, in the past, you might also have learned something called quartiles. Quartiles are the median of the first half of the second half of the data set. So first quartile is the lower half median. So if I were to split the data set in half, so we're going to draw a line, okay? So let's say there are 8 numbers. Well, half of 8 is 4. Let's say if I were to draw a line in between them. Don't you agree? There are 4 numbers on the lower half and then 4 numbers on the upper half. So to find the first quartile, we're going to find the median of the lower half. So since there's 4 numbers, if I were to take one pair out, there's 2 middle numbers in the middle, right? 2 numbers in the middle. So to find the middle numbers of these 2 numbers, you're going to add them divided by 2. So 3 plus 4 divided by 2, which is same as 3.5. So the first quartile is 3.5, or you could argue that 3.5 is right in between 3 and 4. Well, likewise, for the third quartile, that would be the median of the upper half of the data set. So same thing, since there's 4 numbers, you're going to take one pair out, and then you notice that there are 2 numbers right in the middle. So to find the middle number right in between these 2 numbers, then you're going to add them, and then divide it by 2, and you'll get 7.5. Or you could argue that 7.5 is right in between the number 7 and the number 8. Now, not every time you have to add them divided by 2. We do that only because we see that there are 2 numbers right in the middle of the data set. Well, if it turns out to be, let's say this upper half, right? Let's say there's only 3 numbers, then, you take one of them out, and then this number will be your third quartile. But it just happened that there are even number of numbers, so therefore you're going to end up with 2 numbers in the middle, and therefore you're going to take the average to find a third quartile. Well, besides finding centers of a data set, we also could find out how spread out are the numbers in the data set. So one way to determine how spread out is something called interquartile range. Now, since it has to do with interquartile, that means we're going to use these two quartiles, and then range means I'm going to find the differences. So the formula to find an interquartile range would be Q3 minus Q1. Or you could say the third quartile minus the first quartile. Or you could say the larger quartile minus the smaller quartile. So it's going to be 7.5 minus 3.5, which is going to be 4, right? So that means the interquartile range is 4. This also represents the range for the middle 50% of the data set. Okay, so remember, quartile is 25%. It's like, so it's like, if I were to split it into 4 different parts, right? Well, the first quartile separate the first quarter and second quarter. The median separate the second quarter and third quarter. And then the third quartile separate the third quarter and the fourth quarter. Okay, so the interquartile range is the difference in between this line and this line, which is 7.5 and 3.5. So the difference is 4. So this 4 represents the range for the 50%, the middle 50% of the data. Okay. Now, what about just a regular range? Well, the regular range would be just the highest number, which we call it maximum, minus the smallest number, which we call a minimum. So the maximum in this data set is 12, and then the minimum for this data set is 2. So 12 minus 2 is 10. This is just to represent the difference between the largest number and the smallest number. And that's how we measure the spread of the data with interquartile range and range. So once you learn how to calculate all these information, mean, median, mode, first quartile, third quartile, interquartile range, and range, we're ready for the next lesson, 10-2. In 10-2 comparing data sets, our objective is to compare characteristics of displays, including center, shape, and variability. Well, let's talk about shape first. So in a histogram, there are something called peaks. Peaks are pretty much the highest point in a histogram. Sometimes there will be one peak only. This is the highest point, and we're going to call it a unimodal distributions. So to learn these vocabularies, let's actually underline these words. So unimodal means a histogram with just one peak or one highest point. Well, if there's two evenly, it's the same height of highest point. Let's say if this bar is the same height as this bar, we call it a bimodal, right? Which the prefix bi tells you that there is something about 2, the number 2. So in this case, this is a unimodal distribution because this is the highest point. And then the bimodal will have a 2 peaks that are exactly the same. Now, if it's a single peak at the center, right? So let's say if this looks like a mountain, right? We call it a bell-shaped distribution. So bell-shaped because it just looks like a bell, right? And this is another word that you have to learn. So bell-shaped is usually unimodal because the highest point is usually right in the middle of the bell. The next thing that we want to talk about is something called a shapes of distributions. Well, there are different types of shape, and the first shape that I want to show you is something called a symmetric shape. Well, there are 2 types of symmetric. The first one we call it a bell-shaped curve. So as we discussed, bell shape looks like a bell. So in a histogram, a bell shape looks like this because it kind of looks like a bell, right, or like a mountain. And the left side looks exactly like the right side, right? It's symmetrical. And then likewise for dot plot, you see that this dot plot is also bell-shaped, and it starts from low and then gets to the highest in the middle, and then it kind of ends low at the end. And the same thing with box plot. A box plot would be evenly spaced between the little line and the little boxes. So the left will look like the right, as the same as dot plot and histogram. And in a bell-shaped symmetric distributions, your mean and your median are pretty much the same or very close to each other. Now, if they're perfectly symmetrical, then of course the mean and median are going to be exactly the same. And this is one important point of a distributions being symmetric. The next type of symmetric distribution is called U-shape. So this is kind of like the opposite of bell shape, where you start high and then it kind of dips right in the middle, and it's going to end high. Likewise for dot plot and then box plot. You notice that for box plot, the box is much larger than the lines, the segments at the end, but it is still symmetric. The left looks like the right, the left looks like the right, and here the left also looks like the right. Here, your mean and your median is also the same, or at least they're very, very close to each other. They're not different by much, and as well as the mode as well. Now here, let's go back to the bell-shaped curve. All bell-shaped curves are mostly unimodal. Unimodal means there's only one peak right in the middle, right? One peak, one peak, one peak. But for a U-shaped distributions, it's bimodal because the peak's usually at the beginning and at the end of the distribution. So here you have two peaks that are the same height, so we call it bimodal. Likewise here, and you can't really see in the box plot, but mostly in dot plot and histogram. Besides bell-shaped or symmetric or U-shaped distribution, there's something also called skew right. Skew right are pretty much a distributions where you start very high and then it gets lower, 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 creating a tail towards the right. So kind of like this, right? So if I were to draw like a little arrow, it kind of like a sliding to, it's like a sliding towards the right. Same thing with here, right? And in the skew right distributions, the mean typically get pulled toward the tail and is greater than the median. So if I were to put as an inequality here, that means the mean is greater than the median. Okay, so here the mean and medians are not the same. The mean is always greater than the median. And that means more people ended up at the lower part of the x-axis and not a lot of people ended up at the higher part of the x-axis. Let's say, for example, in this real world, there are more poor people than rich people. So most of the people will land it right here, and because they don't have a lot of money, and then the rich people will end up here because they have more money. So in real world, the distribution of wealth or the rich money or richness, right, will be skewed to the right mostly. Well, oppositely, on a skew left distribution, you start very low and then you end up high as you go from left to right. So you see there's a tail extending to the left, towards the left. Well, in the skew left distributions, the mean typically gets pulled towards the tail and it's less than the median. So therefore, I put this inequality. Your mean is always less than your median, or in other words, your median is greater than your mean. In a box plot, the left segment is always longer than your right segment. So that's how you could tell this is a skew left distributions. One real life example is the distribution of a test score of a very easy test in class. So think about this. If a test is easy, don't you agree that most students, right? Don't you agree that most students would get a higher score, so 60, 70, 80, 90, 100%, compared to the students who fail this test, which is around 10, 20, 30%. If a test is easy, there'll be more people passing the test versus people failing the test. So this is an example of a skew left distributions. Will be a very easy test that students take in class. So let's take a look at example 1. It says describe the shape of each distribution to see if you understand. Well, in part A, I see that this graph, I see that it starts very high and then there's a tail kind of like a sliding towards the right. So in this case, we're going to say this distribution is skew right. And then for part B, I see that this is kind of like a very symmetric, not exactly symmetrical, but looks like the peak is right in the middle of the graph, right? And this is a histogram. So we're going to say this is symmetric, right? This is a bell shape, symmetric. Okay, and then for part C, I see that in this box plot, I see that the tail on the right is much longer than the tail on the left. So we're kind of like sliding to the right. So this is also skew right. And that's how you determine the shape of each distribution. In example 2, we're going to take a look at two different dot plots between two class scores. One of them is Miss Wild's class, and then the other one is Miss Steady's class. Well, in part A, it says which class had the higher median scores. Now, this one you kind of have to do some work because you have to extract these numbers. You're going to write them as a number, and then you're going to find the median, okay? So here we're going to write, well, there's a 1 there. And there is 3 5, so we're going to put 5 5 5. Then there's 2 6, and there's 2 7s, and there's 1 8, and 1 9, and 2 10. And we're just going to play the scratch off game. So, you know, we're going to just scratch one number on the left, on the right, 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 on the left, on the right. And I see that the median here is right in between these two numbers, which is 6.5. So this is the median for the Miss Wild's class scores. Now, what about Steady's class? Well, let's actually do the same thing. I see there's 2 6s, and there's a 5 7s, and there's 5 8. So we're going to play the scratch off game again. So we're going to scratch one out. So 1 pair, 2 pairs, 3 pairs, 4 pairs, and 5 pairs. And I see that, you know, I ended up with 2 7s. So the middle number that is right in between 2 7 is just 7. So which class had the higher median score? Well, it's definitely this class, right? Steady's class scores. So we're going to say Steady, just because it has 7 compared to 6.5. Well, what about part B? Part B says which class had the lower minimum? Well, the lowest number for this one is 1 for Miss Wild's class, and then for the lowest number for Miss Steady's class is 6. So it's definitely Miss Wild's class. So we're gonna just write the last name, and then that's it. And then what about part C? Which class has more consistent score? Now, consistent means, you know, numbers that very, very close together. So in Miss Wild's class, I see that there's one person got 1 point, and then they're pretty spread out, right, between 5 to 10. So there's some people who got 100%, there's some people who just didn't know how to do the homework or test, and then most people are around in the middle. But however, on the other class, Miss Steady's class, most people are around 6, 7, and 8. Nobody failed, and nobody really got 100%. So they're really clustered together. They're, you know, very, very close together in terms of the class scores. So therefore, which one has more consistent scores? It's going to be this class, Miss Steady's class. In example 3, we're going to take a look at two different dot plots, and here's the instruction. It says Sawyer has narrowed his car search down to 2 different types of cars. To make an informed decision, he gathers data on estimated highway fuel efficiency of the 2 different types of cars. The data plus shows the data for each type. So this is the highway fuel efficiency for the first type of car. And then here is the highway fuel efficiency for the second type of car. And question 1, it says, if highway fuel efficiency is the most important feature to Sawyer, which type of car should Sawyer purchase? Well, car efficiency means I could drive a lot of miles given just 1 gallon. Well, I see that, well, in type 2, right, the car that's the second type of car, I see that most gas mileage are between 35 to 44 miles per gallon versus type 1, which is around 33 to 41 miles per gallon. So I see that type 2, it clusters around the higher number range versus type 1. So we're going to say, well, that means he should purchase type 2. Okay? Now, question number 2 says, how does the outlier in the second data affects the mean? Well, I see that there is an outlier on the type 2, right? There's, you know, one incident where we have 51 miles per gallon. I don't know why, but it actually happened. So how is it going to affect the mean? Well, remember, mean is adding all the numbers divided by the number of numbers. So if there's an extra number that is very, very high, well, do you think the mean is gonna get higher, lower, or stays the same? Well, since there is a higher number and it's much higher than the rest of them, it's gonna affect the mean higher. So we're going to say, well, the mean will be higher. So we're gonna write it down. The mean will be higher. One example for this time, we're going to take a look at two different box plots. So here's the problem. It says Kaylin and Philip go to neighborhood high schools and both are sponsoring charity fundraisers. Kaylin claims that students at her school are raising more for charity than the students at Philip's school. The amount of raised by a random sample of 30 students at each school are shown in the box plot below. Do the data support Kaylin's claim? Let's review what's Kaylin's claim again. Do the data support Kaylin's claim that the students at her school are raising more money for charity than the students at Philip's school? Let's take a look. I see that in the box plot, the minimum is the same and the maximum is the same. You know what? Let's actually write out those numbers, right? So I see that in the box plot, the minimum, this is about 25, and the maximum is 68 and 68. Now, remember in the box plot, these three numbers are first quartile, median, and the third quartile. So the first quartile for the Kaylin school is 32, the median is 45, and the third quartile is 52. And then for Philip, it's going to be 45, and then this is 50, and then this is 56, okay? Well, let's take a look at the 50%. Remember, between the two quartiles, this represents 50% of the data, 50% of the students at the school. So we're going to say this is 50%, okay? And likewise, this is also 50%. Well, I see that half of the people in Philip's schools, well, donated between $45 to $56. But in Kaylin's school, 50% or half of the people only donate $32 to $52. So if I were to answer the first questions, do the data support Kaylin's claim that students at her school are raising more money than the students at Philip's school? The answer is no, because I see that 50% of the people at Philip's school donated $45 to $56, which is way more than $32 to $52. Well, question 2 says, how does the IQR interquartile range of the money donated compare to the range for Kaylin's school and Philip's school? Well, the interquartile range, remember, let's actually draw a chart. So we're going to say Kaylin and Philip. Now for the IQR for Kaylin's schools, we're going to subtract these two numbers. So 52 minus 32, which is going to be 20. So Kaylin's IQR is 20. What about Philip's IQR? So it's going to be 56 minus 45, which is 9. Well, that tells me that, well, at Philip's schools, people cluster more around donating between $45 to $56. But at Kaylin's school, the 50% of people kind of spread out, right? I mean, some people donated much less and some people donated much higher. So how do we compare with the IQR? We're going to say that, well, in Philip's schools, the people donated, it's much cluster, or much more concentrated in terms of the money compared to Kaylin's school. Well, what about range? Well, I see that the range, well, are pretty much the same, because range is just the difference between the maximum and the minimum, which is 68 minus 25, and they're both 43. So the range is the same between Kaylin's and Philip's schools. While there's somebody donated the highest amount, which is $68, and then there's somebody donated not so much, which is $25. Well, lastly, let's take a look at the last two examples, example 5A and 5B. Well, here it says Kaylee is working on a project investigating the number of music downloads students in different grade levels performed the previous week. Kaylee thinks that the 10th grader download more music than 11th graders. Is Kaylee claim support by the data? Why or why not? Well, let's take a look at the number of downloads by the 10th grader. Well, again, we have a box plot. And the 5 numbers, which is the minimum, first quartile, median, third quartile, and the maximum will be 2, 4, 5, 7, and 8. Well, for the 11th grader, it will be 2, 3, 5, 7, and 9. So to find out how many people or which grade level has more music downloaded, remember, we always look at, or we usually take a look at the middle 50%. So the middle 50% for the 11th grader is between 3 to 7 downloads of music, or between 3 to 7 songs in this case. And then for the 10th grader, well, the 50% of the people download between 4 to 7 songs. So I see that, well, for the 10th grader, the number of downloads cluster around 4 to 7 compared to the 11th grader, which cluster a little bit less, between 3 to 7 songs. So to answer that question, well, Katie thinks that 10th grader download more music than 11th graders. Is it true? The answer is yes. Why? Because if you take a look at 10th grade, well, half the people download between 4 to 7 songs, and in 11th grade, half the people download between 3 to 7 songs. So even though these two numbers are the same, the median and the third quartile, well, the first quartile for the 10th grader is larger than the first quartile for the 11th grader. So we're going to say, well, 10th grader downloaded more music compared to 11th grader. Well, in example 5b, let's take a look at two different grade levels again. This time it's 11th grader and 12th grader. Same thing, same prompt. It says, well, Kaylee thinks that the 11th grader download more music than the 12th grader. Well, is she correct? Why or why not? Well, same thing. Let's actually write out the 5 numbers that is displayed in the box plot. So the minimum for the 11th grade is 2. The first quartile is 3. Median is 5. Third quartile is 7. And then the maximum is 9. Then for 12th grader, the minimum is 1. The first quartile is 5, median is 6, third quartile is 7, and then the maximum is 10. Well, let's take a look at the middle 50% of the people. So in 11th grade, the middle 50% downloaded between 3 to 7 songs, where in 12th grade, the middle 50% download between 5 to 7 songs. So apparently, we could see that 12th grade download much more music, right, from 5 to 7 songs compared to 11th grade, which is just 3 to 7 songs. So is Kaylee's claim correct that she thinks that 11th graders download more music than 12th graders? Well, the answer is no this time. Why or why not? Because again, the 50% of 12th graders download 5 to 7 songs, where in 11th graders, they only download 3 to 7 songs. Half of them download 3 to 7 songs. So that's pretty much it for the entire lessons. Your next couple minutes will remind you how to log into your Pearson's homework to work on these comparisons. Thank you so much.
Hey everyone, so to get to your homework, first you go to my CNUSD website and then you click on the top of the page, my CNUSD, to log in. Well, you're going to type in your username and your password. Well, in this case, your student ID and your password. Then you go on to resource. I think for you guys it's resource. And then you go to a place called Pearson Savas Easy. Pearson Savas Easy. I'm not quite sure how you say that word, but it's Pearson Easy. Click on that. And you get to this pop-up page. And you're going to click on your class textbook. So you click on this right here. This is called Envision Integrated Mathematics 1 2009 Common Core. You click on that, a new window pop up again, and you see 3 different colors. The green color is your online textbooks. I teach from this textbooks. So if you don't have a copy, an actual copy, you could always go to here and click on the appropriate sections that we're teaching. But to find your online homework, you look at the reddish, orangish box in between, in the middle. It's called classes. So you're gonna click on here, click on classes, and depending on which period you're in, there will be new assignments here. So you're going to click on the click into the assignments, and then do your homework, and then that's it. Well, inside the homework, there are problems for you to work on, which allow you 3 attempts before they give you the final answer. So for example, for this problem, if you accidentally got a wrong answer, it'll tell you keep trying. Then you type in another answer, and if it's wrong, then it'll give you one more chance. And the third time that you got it wrong, it'll tell you the answer right away. So, but you could always get help by viewing an example on this part of the feature. So it'll tell you what to do step by step until the final answer. So you could always refer to the question, help view an example, or you could use help me to solve this to actually work it step by step. So there will be more answer boxes for you to fill in, but at least it will help you on your learning. Now for this problem, what do you do when you get it wrong, right? So to get a point or to get scores on that homework, then you click on similar questions and you keep practicing until you get it right. So if I were to click on similar questions, you notice that the questions changed. It's different from the previous one. So let's say this time you got it right. Let's say x is equal to 5, right? Well, if you got it right, it will tell you well done, okay, and then you move on to the next problem. So you click on next to move on to the next problem, like this. And once you finish all the problem, I believe the next thing is for you to make sure that you answer all the questions. If there's anything that it's not answered, make sure that you go back and look at it like this, right? So this is not answered. But let's say assume that if you finish your all of the questions on your homework, then you go to the bottom, I believe. Oh, actually, this button right here says submit my work. So you click on it and then boom, I only got 3% just because I only answered one question correct, the rest I did not answer. So in order for you to get at least 80% or any good scores, make sure that you answer every single question and it's correct, not incorrect, for you to get as many points as possible on your homework. If you have any questions, please contact me.